to look at subtracting with algebra graphically. So when we looked at adding graphically with algebra, we looked at drawing visual representations of the different terms, whether they were x squareds, x's, or constants or numbers. We're going to do the same thing here, but we need to think about the concept of opposites. So we consider the values of 4 and -4 to be opposites. We can use the same idea for algebraic terms. So when we're looking at algebraic terms, remember we can have just a number, which we call a constant. We can have a combination of a letter and number, and sometimes we can have a combination of a letter, number, and an exponent. So when we're looking at the algebraic term of -5, the opposite of -5 would be +5. So I would just write +5 in this area. The opposite of 2x would be -2x. So we're just switching the signs. So if it's positive, it becomes negative. If it's negative, it becomes positive. If it's -4x, it becomes +4x. 3x squared, the opposite term is -3x squared. -5x squared is 5x squared. So now when we're looking at visualizing a polynomial, we need to think about what that means in terms of subtracting them. So when we see a negative in front of a polynomial, we can interpret it as the opposite of the polynomial inside of the bracket. So every term inside of that bracket becomes the opposite term when you're subtracting. So let's take another look at this. So let's take a look at this polynomial. So if I just have a monomial, so that's what 2x squared is, it's just one term. The graphical model of this polynomial, so 2x squared, would be two large x's, x squareds, so two large squares to represent my 2x squared. The graphical model of the opposite polynomial would be the two large squares, but this time they're colored in to show that they're negatives. -3x squared, the graphical model of that would be three large squares shaded in to represent that those are negatives. And the opposite model, so the graphical model of this is opposite, where we would just draw the same shapes but different colors. So if they're shaded in, they become unshaded, and if they're unshaded, they become shaded. So the graphical model representation of -3x squared is +3x squared. When we're looking at more than one term, so for example, the next one is x plus 2. This is a binomial. It has two terms that are being added or subtracted together. We want to think about, first of all, what the graphical model of the original polynomial would be. In this case, it would be a rectangle to represent the x and two small squares to represent the 2. So now when we're drawing the opposite polynomial, same thing applies if it was just one term. We would draw the same shapes but different colors. So we have our -x and then we have our -2. So both of these shapes become the opposite. Same thing with 2x minus 3. I start out by drawing my original polynomial, two x's or two rectangles, and three shaded in small squares to represent -3. So when I'm drawing my opposite polynomial, I am drawing two rectangles that are shaded in. This is for -2x now, and then three small squares unshaded to represent +3. So you'll notice again, when they're positives, they become negatives, and when they're negatives, they become positive. And we're going to take a look at some examples when we have trinomials. So this is three terms separated by addition or subtraction signs. We're starting out with 3x squared, so three large positive squares. 2x, so two rectangles. And 4, so four small squares. and the opposite polynomial. So all of these are going to be the opposite colors. So I have 3x squared, but these are negative, so negative 3x squared. And then I have negative 2x. So I'm going to have them shaded in, negatives. And then I have negative 4. So 4 small squares shaded in. And lastly, negative x squared. So that's 1 large square shaded in, negative. Negative 3x, so 3 rectangles shaded in. And positive 1, so 1 small square. And the opposite polynomial would be 1 large square, so positive x squared, and then 3 rectangles, so positive 3x, and 1 small shaded in square, so negative 1. So that's important. Again, it's helpful for the visual learners to see these shapes graphically, so visually. We're going to also take a look later on how to not use these graphical representations, but how we can just use the concept of what we learned in these couple of lessons to simplify that procedure a little bit. So now we're going to not only write the graphical model of the polynomial, so this is going to be the polynomial when we've looked at the negative sign, so we're going to draw that opposite of what it would be, but we're also going to write the simplified algebraic model of the polynomial. So now we're going to combine the graphical representation with the algebraic representation. So if I have negative and then 3x minus 2, so you'll notice my polynomial is inside of a bracket. So this shows that the negative sign gives an opposite representation to both of these terms inside of our bracket. So instead of 3x, we're doing negative 3x. So I have 3 rectangles shaded in. And instead of negative 2, I'm drawing positive 2, so 2 small squares. So the simplified algebraic model of that polynomial would be negative 3x plus 2. So I have 3 rectangles that are shaded in, so negative 3x and then plus 2 constants or numbers. The next one, we're going to again take a look at what you have inside of the bracket, and you're going to make each of those terms the opposite representation. So instead of 2x squared, we're going to make them negative. So 2 large squares shaded in. Instead of a negative x, we're going to make that a positive x. So 1 rectangle. And instead of negative 3, we're going to make that positive 3, so 3 small squares. And the graphical representation now in an algebraic form would be negative 2x squared plus x plus 3. So it's the opposite signs in our simplified algebraic model if we have a negative sign in front of that bracket. And the last one we're going to look at in this representation is our negative x squared plus 2x minus 1, but we're subtracting this. So again, all of these terms become the opposite representations. So instead of negative x squared, it's a positive x squared, so a large square. Instead of 2x, it becomes negative 2x, so 2 rectangles shaded in. And instead of negative 1, it becomes positive 1, so 1 square, 1 small square. And the algebraic representation of that is a positive x squared. I don't need to write the positive sign in the front so in front of my first term, although if you do, it's not wrong. And then I have 2 negative x's, so negative 2x and a positive 1. So now we're going to combine that. We're going to take it one step further. So now we have algebraic expressions. You'll notice that each expression is inside its own bracket, and we're going to subtract these algebraic expressions. So the first expression stays exactly the same because there is no negative sign in front of this bracket. So I'm going to draw my shapes as if it was just a regular expression. So I'm drawing 3 rectangles for 3x, and I'm drawing positive 2, so 2 small squares. The second one is the one that you're going to look at this negative sign. So the negative sign tells you that anything after that, inside that bracket, becomes the opposite representation. So instead of 2x, it's going to be negative 2x, so 2 shaded rectangles. And instead of positive 4, it's going to be negative 4, so 4 small shaded squares. When we looked at adding polynomials, we looked at the opposite shapes being what we call like terms. So when they have the same shape, they're like terms, but if they're one of each, so one positive and one negative, they would cancel each other out. So that helps us simplify that expression. So in this case, when I'm looking at this, I have a positive and a negative, so those are gone. I have another set of positive and negative x's, so those are gone. So I'm just left with a positive x. When I'm looking at my small numbers, so my constants, I have one small square and one negative square. They cancel each other out. And I have another set as well. And I can cancel those ones out, so I'm left with negative 2. So using that is very helpful for us to simplify that expression. So next example starts with 2x squared minus 1. So I'm drawing 2 large squares. These are not shaded in. So let's try to fix that for you. So I have 2 large squares, and then I have a negative 1, so 1 small square shaded in. And now this negative sign tells us that everything in this bracket is the opposite sign. So instead of 3, I'm drawing negative 3, so 3 squares shaded in. And instead of x squared, negative x squared, I'm drawing a positive x squared, so 1 large square. So now when I'm simplifying this, I look at my largest shapes first. So I have 1, 2, 3 positive x squared, so 3x squared. And I have 1, 2, 3, 4 negatives, so negative 4 just regular numbers. So there was nothing to eliminate in that expression. Moving on, I have 3x squared, so 3 large squares. Negative 2x, so 2 rectangles. These ones are shaded in because they're negative. And positive 2, so 2 small squares. I'm looking at my negative sign, so everything in that bracket after that becomes the opposite sign. So instead of x squared, it's negative x squared, so 1 large shaded square. Instead of positive 3x, it's negative 3x, so 3 rectangles shaded in. And instead of negative 1, it's positive 1, so it's 1 small square. So I first look to see if there's anything that I can eliminate. So do I have any like terms that are opposites? So I have 1 positive x squared and a negative x squared, so those can be eliminated. So I'm left with 2 positive x squared, so 2x squared. Then I look at my x's. These are all negative, so I have 1, 2, 3, 4, 5, so negative 5x. And I'm looking at my constants or my numbers. So 1, 2, 3, those are all positives. So my simplified expression is 2x squared minus 5x plus 3. And the last one is 2x squared. So I have 2 large squares. Negative 3x, so 3 rectangles shaded in, and positive 1, so 1 small square. My negative sign here, so I'm subtracting, so everything in this bracket is the opposite sign. So instead of 3, it's negative 3, so 3 small squares shaded in. Instead of negative x squared, it's a positive x squared, so 1 large square. And instead of negative 3x, it's positive 3x, so 3 rectangles. So again, I'm going to simplify this now. So I'm starting with my x squared, so my largest shape. So I have 1, 2, 3 positive x squareds. When I'm looking at my x's, so my rectangles, I notice that I have some opposite signs that I can eliminate. So I can get rid of 1 set, 2 sets, and 3 sets. So all of my x's are gone. And now when I'm looking at my numbers or my constants, I have 1 set that I can eliminate. So I'm left with negative 2. So this simplified expression becomes 3x squared minus 2. And then if I wanted to state the type of polynomial that each of these questions represented, so the simplified algebraic model for each of these questions, I would look at how many terms I have in my expression that are separated by addition and subtraction signs. So I have 2 terms in the first one, so this is a binomial. So remembering those terms from before. The second one, I have 3x squared minus 4, so those are 2 terms, so that's another binomial. The third one, I have 2x squared minus 5x plus 3, so 1, 2, 3 terms, that's a trinomial. And lastly, 3x squared minus 2, those are 2 terms, that's a binomial. So it's always good to refer back to those terms that we look at and learn in previous lessons so that we are still keeping those fresh in our mind.